Hey everybody, it's Miss Berry. In this video, we are going to cover section 1.2, which is called problem solving, processes, and techniques. All right, so I'm going to flip the camera around and we'll go ahead and get started. All right, so problem solving, processes, and techniques. So in this section, they employ the use of George Poya's four-step problem solving process. George Poya was a Hungarian mathematician, and he's known as the father of problem solving. He's a pretty interesting guy. He passed away in 1985, but a lot of his lectures are available on YouTube. And yeah, he's a cool guy if you ever want to, if you're interested in applied math or in math education. So he established this four-step problem-solving technique that can be used really in any situation, but it's especially helpful when you're solving math problems. So here's the 4 steps. Step 1 is understand the problem, develop a plan, carry out the plan, and then look back. I just realized I have a typo there that was supposed to be understand the problem. So I fixed that. Okay, so let's talk about each of the steps individually. Step 1, understand the problem. I'm just going to type out some important stuff for each step instead of writing it because my handwriting is a little sloppy on this app. So before you can start working the problem, it's important that you begin by understanding what the question is asking, or asking for, we'll say. In this step, you may need to do stuff like assign variables, reread the problem several times, and then as you reread, sort of identify important information and even eliminate information that is unnecessary. There we go. I can never spell unnecessary right. Okay, so it's important that you begin by understanding what the question is asking for. Within this step, you may need to do stuff like assign variables, reread the problem. While you're rereading, identify important information and also eliminate information that is unnecessary, that you don't need to solve the problem. The second step, once you understand the problem fully, then you can develop a plan for solving the problem. So there's a lot of different problem-solving strategies that your book lists. I'm just going to write out some of the ones that I think are most useful. So you can look for patterns, find patterns, start by solving a simpler problem, and then extend your findings using the pattern you identified. You can try to work backwards. You can guess and check. So just, think of some guesses for your answer. Once you maybe have an idea of what the numbers should look like, then you can try to work backwards. You can draw a picture, or use things like a variable to take the place of any unknown values. All right, so as I'm going through this, you may need to pause the video to, write everything down. Oh, let me see if I can scoot that over a little bit. There we go. All right, so once you've developed a plan, the next step is to carry out that plan. All right, so use your strategies from step 2 to solve the problem. Use some of those problem-solving strategies that you identified in the second step to solve the problem. That's the third step. And then the last thing you're going to do is just look back. You can think, does my answer make sense? I was trying to make that capital. There we go. Does my answer make sense in the context of the problem? You can ask yourself, what worked here? What didn't work? This is helpful when solving similar problems. So asking yourself, what worked here? What strategy did I use to answer this problem? And then you can sort of, use that strategy on future problems that look similar. All right, so that's our 4 steps. Understand the problem, develop a plan for solving the problem, carry out that plan, and then look back, think, does my answer make sense in the context of this problem? What worked? What didn't work? And then you'll be done with the problem-solving technique. All right, or problem-solving process. All right, so we're going to start off with a sort of a fun problem, and then we'll work our way into some more complicated problems. So the first problem says, place the numbers 2 to 10 inclusive. That means you have to include the numbers 2 and 10. So place the numbers 2 to 10 inclusive in the magic square so that the sum of the numbers in each row, column, and diagonal is the same number, 18. All right, so step 1 is to understand the problem. So let's talk about what we're doing here. Our whole goal is to place each of the numbers 2 to 10. Let's write them off. 2, 3, 4, 5, 6, 7, 8, 9, and 10. To place each of these numbers in these little squares. You can only use each number one time. And we're going to fill in this square in such a way so that each of the columns, so columns go up and down, each of the columns adds to 18. Sum means add. So that each of the columns adds to 18, each of the rows adds to 18, and these diagonals here add to 18 as well. All right, so let's go ahead and mark off. We can't use 5 and 8. Those are already used in our problem. So 5 and 8, we can't use those. Really the only way to solve this is just to start by making a guess. So let's see, if I was looking here, if I know that this row has to add to 18, so 5 plus what will give you 18? That would be 5 plus 13, right? So these two have to add to 13. All right, so we could do like, you couldn't do 5 and 8, right? 5 and 8 would add to 13, but each of those numbers is already being used, so you can't use those. You could use 7 and 6. So let's try that one. So we'll do 6 and 7 right there. I'm just going to erase these extra things so we don't have too many numbers floating around. All right. So 6 and 7. All right, so now let's look here. What would we fill in the middle here if this needs to add to 18? 8 plus 6 would be 14. So how much more would we need to put here to get to 18? That would be 4, right? Okay. Now let's go this way. You could go up and down. You could do either diagonal. Let's see here. 7 plus 4 is 11. 11 plus what will give you 18? That would be 7, right? Well, we couldn't do 7 there because we already used 7 one time. All right, so that's not going to work. All right, so just keep in mind that that one didn't work, that combination. So let's erase this and start over. So 6 and 7 across the top is not going to work. All right, so let's erase those. Start over. All right, so let's see. What else adds to 13? Remember, because we said 5 plus 13 is going to give you 18 in this row. So we said we can't use 5 and 8, 6 and 7 didn't work. What about, let's see, 9 and, well, we couldn't do 9 and 9, right? Because you can't use 9 twice, so that one's out. I'm sorry, I said that wrong. 9 and, this only has to add to 13, right? So 9 and 4 would give you 13, so let's try that. We'll do 9 and 4. All right, so let's make sure that adds to 19. 5 plus 4 is 9. 9 plus 9 is 18. Okay, so that works. Now let's fill in the rest of this. Just marking through what we have already used. We used 9 and 4. All right, so what about here? 8 plus 4 would be 12. And then we would need 6 more to get to 18. All right, so now let's check, make sure that adds to 18. 4 plus 6 is 10. 10 plus 8 is 18. Okay, so now let's do this diagonal. 5 plus 6 is 11. 11 plus 7 would give you 18. Now let's go up and down here. 9 plus 7 is 16. So you would need 2 more to get to 18. Now let's do the rows. 6 plus 2 is 8. So you would need 10 more to get to 18. Let's cross off what we've already used. Okay, we used 10. We use 6, we use 7, we use 2. Our last number here has to be 3, so let's check and make sure that works. 5 plus 10 is 15. 3 more would give you 18. So there we go. This is our magic square all filled in. So we sort of developed a plan. We said, okay, we're going to just look at this row. We know that these two pieces need to add to 13. And then we went through our options for what two numbers can add to 13. You could have also tried 10 and 3. That may have worked. It just so happened, I was sort of just looking here like, 5, 6, 7, 8, 9, going in that order. That was sort of my thought process. And our magic squares filled in. So I wouldn't put something like this on the test, but it was just sort of a fun problem that we could start off with. Let's look at the next problem. Way down here. All right, find the sum of the whole numbers from 1 to 820. Okay, so it wants us to, whole numbers are going to be numbers like 1, 2, 3, 4, 5, and so on. All right, so it's wanting us to find the sum of all of the whole numbers all the way to 820. All right, remember sum means add. All right, so this would take us a really long time to plug this all in our calculator. So we want to develop come up with an idea of what we can do that would be easier than that. All right, so we understand the problem. We understand that we need to figure out what are you going to get if you add all these numbers up. I think a good plan here is to start off with a simpler problem. So let's start off by looking at just a part of that problem. Let's just look at the numbers 1 to 10. Okay, let's see what the numbers 1 to 10. Whoops, that's 8. Try that again. 8, 9, and 10. So let's add up 1 to 10. Then we'll see if we can find a pattern and maybe extend that pattern to 1 to 820. All right, so add that up on your calculator. Let me pull up my calculator. Okay. All right. Sorry, I had not adjusted my camera before we started. All right, let me focus that. Okay, 1 plus 2 plus 3 plus 4 all the way to 10. Whoops, I messed up. Let me start over. Oh my goodness. Okay, there we go. Okay, 1 plus 2 plus 3 all the way to 10 is 55. Okay, let me zoom out a little bit. That's perfect. All right, so all of that adds to 55. So let's see if we can just identify sort of maybe a pattern here. I'm going to leave the calculator up on the screen because we're going to have to use it in a minute. Okay, so what are two numbers that multiply to give you 55? 11 and 5, right? So 11 times, let me do that in a different color. 11 times 5 would give you 55. All right, let's see if we can find out maybe a pattern with these numbers, 11 and 5. Let's look at some pairs of numbers. Let's look here, 1 and 10. What do those add to? 1 plus 10 would be 11. Okay, let's look at another pair. 2, sorry, that's hard to see. Let me use a different color. What about 2 plus 9? That adds to 11. All right, what about 3 and 8? That also adds to 11. 4 and 7 add to 11. And then finally, 5 and 6 add to 11. So each of those little pairs added to 11. All right, so let's see how many pairs there were altogether. All right, so there was 1 pair, 2 pairs, 3 pairs, 4th pair, and then altogether there was 5 pairs. And look, so that's where that number comes in, 5. All right, so each of the pairs added to 11. So this is the sum. Let me try that again. Sum of each pair. And then 5 was our number of pairs. Now, another way to find the number of pairs is just going to be half of whatever that last number right there is. All right, so the last number was 10. Half of 10, 10 divided by 2 is 5. So that's how many pairs there were. All right, so it looks like if we're looking for the sum of the whole numbers, all you'd have to do was, if this pattern works, which it does, all you'd have to do is find the sum of each of the pairs, and then find the number of pairs, multiply those, and that's going to give you the sum. Sorry about that. Now let's see if we can extend that to our problem where we're looking for the sum of the whole numbers from 1 to 820. All right, so we're doing 1 plus 2 plus 3 all the way to 820 equals, and then we're looking for that number. So this is all going to add to some number, and according to our pattern up here, it's going to that number is going to be able to be broken down into the sum of each of the pairs. So the sum of each pair times the number of pairs. Okay, so remember we started off our pairs, went for the first one and the last one, so we can easily find the sum of the pairs here. First one and last one would be 1 plus 820, which is 821. Okay, so that's the sum of each of our pairs. You could do this, you could make sure that this works. You could add up the next pair. 2 plus, it would be 819. That adds to 821 and so on. So this is 821, the sum of each pair. And then the number of pairs, remember we said it's going to be half of the last number here. So 820 divided by 2, that's 410. 2 goes into 4, 2 goes into 8 4 times, 2 goes into 2 1 time, 2 goes into 0 0 times. So 410. And now we just need to multiply these. That's going to tell us our sum. All right, so 821 times 410, and there's our sum. All right, let's write it in red. 33, 66, 10. There we go. And this will work for any problem that looks like this, where you are finding the sum of the whole numbers. So Just depends on, your answer will change based on whatever your last number is here. Okay. All right, let's look at this one. This is a good question for the test. It says a number is multiplied by 8 and that product is added to 4. Product means multiplication. The sum is equal to the product of 4 and 13. Find the number. All right, so let's try to understand the problem. Some number, we don't know what it is, we'll just use the variable x to represent that number. Some number x is multiplied by 8. All right, so 8 times x. And that product, so this is called a product because we're multiplying those. So that product is added to 4. And it says this sum, this is called a sum because you're adding them. That sum is equal to the product of 4 and 13. So that's equal to 4 times 13. So find that number, find x. All right, so let's first figure out what is 4 times 13. 4 times 13 is 52. All right, so 8 times x plus 4 equals 52. Sorry, I had my hand covered up my mouth just then. I didn't realize it. Now let's work on solving this for x. So this is called a linear equation. It's called a linear equation because if you graph it, it looks like a line. So that's called a linear equation. We're going to start off by doing 8 times x. 8 times x is just 8x, very simple. Just write them side by side. All right, now we're going to try to get x by itself. So the first thing we need to deal with is this plus 4. So go ahead and subtract 4 from both sides. That is going to cancel this out. And then you have 8x on the left. 52 minus 4, what's that, 48? All right, now you can probably guess what my next step is. I have 8 times x, so I need to divide by 8 so that I can get rid of that 8. I want to get x by itself. Then I'm left with x, and 48 divided by 8 is 6. So there's that number. So the number is 6. Then you could plug it back into the top and just make sure it works. 8 times 6 is 48, plus 4 is 52. And we said that's what 4 times 13 is. Yeah. I accidentally hit enter twice. That's why that came up twice. Okay. And like I said, this is a good test question. Let me just put a little star beside it. So that's a good test question. All right, let's look at the next one. And also, I'm not really mentioning the problem-solving strategy as we're going through, but, we read through it. We understood the problem. We wrote down, we translated the sentence into mathematical language, and then our plan was to just solve this what's called algebraically for x. And then we can look back and we checked our answer, we plugged it in and made sure we didn't make a mistake. All right, we have a couple more problems. Let me see. Yeah, 2 more problems. Let's look at this one. This is another good one for the test. So let me make a little star here. All right, so it says a president and a vice president for an honor society are chosen from 8 people. How many different president/vice president combinations are possible? All right, so you have a president position. I'm just going to put a little box for that, and then a vice president position. Put a little box for them. All right, so we have 8 people in this honor society. So that means for the president, there are 8 people to choose from. So you have 8 choices for president. Now, what about for vice president? We've already picked someone for president. This person cannot be the president and the vice president. So how many people do we have to choose from now? Now we have 7 people to choose from, right? So now we're going to use what's called the principle of multiplication, or the multiplication principle. This is a part of combinatorics. So let me write this down. This is called the multiplication principle. in the branch of mathematics called combinatorics, which is just the mathematics of counting. That's an S on the end, combinatorics. So in the multiplication principle, it says that if you are counting up the different combinations, you just need to multiply these numbers. So 8 times 7 means there are 56 combinations total. Now you could have wrote out all the different combinations, like for example, maybe identified each person as like a letter A through F. Nope, that would be H, right? That would be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you could have wrote out all the different combinations for president and vice president. Like you could have put A and B, A and C, A and D, and so on. But since there are 56 combinations total, that would have taken a really long time. So I think this is a better strategy. So just you want to kind of remember that multiplication principle for the test. All right, so we understood the problem. We said, okay, we know that we're looking for how many different combinations there are. Our strategy was we just drew this little picture. Then we thought of, okay, how many different options do I have for the first position? How many different options do I have for the second position? Then I carried out my plan. I employed what's called the multiplication principle, which told me that I could just multiply these values to tell me the total number of combinations. And I just want to point out here that you would have to list many more there if you were listing them all out by hand. Okay, and then the last one, this is a more challenging problem. It says Scott pays $2.87 in postage to mail a gift card to a friend. All right, so he's spending $2.87 in total. It says he uses 43-cent stamps and 8-cent stamps. How many of each stamp did Scott use? All right, so let's think about what it's asking for here. It's asking us to find the number of stamps. Okay, so it's asking us to find how many 43-cent stamps and then how many 8-cent stamps. All right, so we'll come back in at the end and fill in these little boxes here. So let's think of how we could do this. The way that I'm going to show you is a little bit different than the way your book's going to show you. But we're employing some of the same strategies. So I like to use the strategy that's sort of similar to what we just did with the what we did in number 3 up here. Let me see if I can get it backed up. There we go. So I'm going to set up a little equation and then try to solve that equation. And we will have to do some guessing and checking. But this, to me, makes the most sense to do it this way. So I'm going to set up a little algebraic equation. So I know that my total has to add to $2.87. Let's say that my 43-cent stamps, I'm going to call those X. And then my 8-cent stamps, I'll call those Y. All right, so I assigned my variables. 43 cents, if you were writing that in terms of dollars, that would be 0.43 times X. So that's how many 43-cent stamps that I'm using, or Scott is using. And then 8-cent stamps, that would be 0.08 times Y. All right, so one thing that someone in the class earlier, I just went over this earlier in one of my classes, something that they suggested that I think is a good idea is to go ahead and just shift this decimal over so you're working with all whole numbers. That makes it a little bit easier. So you're just going to move each of these decimal places over twice. So just moving 1, 2 places each time. Okay, so that leaves you with 43x plus 8y equals 287. And these numbers are just a little bit easier to work with. I know sometimes people don't like working with decimals. Now, here's where this is where the guessing and checking kind of comes in. All right, so we're going to go off to the side and do a little bit of scratch work over here. What you want to try to find out is what is the maximum number of 43-cent stamps that Scott could have bought, because you know that he's going to use the most that he can of those 43-cent stamps, and then whatever's left over, he's going to use the 8-cent stamps. You don't want to use like 58-cent stamps. We want to use as few as possible. So we're going to try to maximize the number of 43-cent stamps that we have to use. So let's find the max number of 43-cent stamps that Scott could use. All right, so the way that we could do that is just to take your total, 287, and divide it by 43. That's going to tell you the maximum number of 43-cent stamps he could have used. All right, so 287 divided by, when I did divided by, I just used that little button right there, divided by 43. All right, 6.67, blah, blah, blah. All right, so this tells me that the maximum number of 43-cent stamps that he could have used was 6. So max number equals 6. So that's the maximum number of 43-cent stamps that Scott could have put on his package. All right, so let's see what happens if we plug in 6 for X. All right, so X is the number of 43-cent stamps. Let's go over here. Let's try to plug in X equals 6. This is where our checking comes in. We've made a guess. Now we'll check. All right, 43 times 6 is 258, plus 8y is 287. This again is just a linear equation. Now we can just subtract 258, subtract 258. Whoop. All right, there we go. Now it goes away. Over here cancels out. 8y equals 287 minus 258 is 29. All right, so now you want to ask yourself, okay, if I divide both sides by 8, does 8 go into 29 evenly? No, it does not. So that didn't work. So the maximum value didn't work. Let's go one down. So let's try one down. Let's try 43 times 5. Let's say he used 5 of the 43-cent stamps. So everything stayed the same. I just changed the value of X, went from 6 to 5. All right, so 43 times 5 is 215. Now this process is going to be very similar. You're just going to subtract the 215 over. Okay, so that leaves you with 8y, whoops, equals 287 minus 215 is 72. All right, and can you divide 72 by 8 evenly? Yes, you can. 8 goes into 72 9 times. All right, so this works. So that means we're going to use 5 of the 43-cent stamps and 9 of our 8-cent stamps. Okay. So hopefully you learned some strategies here. So, and just to reiterate, in this last one, we started by thinking, okay, what is this question asking? We wrote down what it was asking for. We assigned some variables. We identified a problem-solving strategy to set up an equation. We went ahead and shifted this over a little bit just so we had all whole numbers to work with. And then we talked about how it would be a good idea for Scott to try to maximize the number of 43-cent stamps that he would use. We tried using the max value, which was 6. To find that max value, remember we just took the total, 287, divided by 43. That tells you the maximum number of 43-cent stamps you could use. But that did not result in us getting a good number for Y. So we went one down. We said, okay, well, maybe he didn't use 6. Maybe he used 5 of the 43-cent stamps. Then we repeated the process. We plugged it into our equation, solving for Y. Y is the number of 8-cent stamps. And we were able to get a whole number value for Y. So that is our answer. All right, so hopefully you can use the 4-step process, George Poya's 4-step problem-solving technique for the other word problems that you'll find in the homework and maybe in the practice test. But like I said, if you get stuck and you can't figure something out, please let me know. You can take a screenshot of the question or write it down, email it to me, or bring it into class, and I can help you with it. Other than that, I hope you guys have a great day, and I will talk to you soon.